Hi guys, it's Brian here. We're working on TI Design 1070. I'm working currently in the building automation team for industrial systems. So this design is basically used to detect when you have airflow efficiency issues with your filter. So instead of taking your filter and replacing it based on a certain amount of time or based on how long your system runs, it's based on the efficiency of airflow through your system. So we'll go ahead and get started, and I'll show you how we set it up. So the first thing we're going to do, we've got our output here. This is how the technician can actually diagnose problems too. We have the UART system here. We have our power coming from this currently, but the power actually will come from the 24-volt transformer in the air handler. This right here is going to signify our signal from the 3.3-volt relay to let us know that the system's on so we can start polling. So the first thing we're going to do is we're going to plug this in right here, and if you look, we've got 100. This is essentially our state that we're in, which we're in state 1, and that is letting us know that we have not been calibrated. So what we'll do is we're going to come over here. This is our system. As you can see, we have this is an inline fan simulating our airflow. Right here we have the button that we're going to press for setting the calibration of the system. So I'll press this button, and as you'll see on the UART screen over there, we'll actually calibrate the values. And here we go. So we're going to take 100 values and average it out to calibrate to what our system should be in normal operation. So we're at state 5, and the second one is going to be our sample number. We're going to go from 0 to 19 for 20 samples per window size. 0 is going to be our probability counter. That is what lets us know that we have a probable filter issue, so we won't alert the user if there's a false alarm. And then the next number is going to be the differential between the two. So I'm going to go ahead, and if you come back over here, you see we have two filters, or we have two sensors, one right here and one right here. This is kind of like the same setup I've got at my house when we do that testing. So this one is simulating being mounted to the blower, and this one is simulating being near the filter. So what I'm going to do is I'm going to block the airflow here, and when it senses the change on the UART, you will see the probability counter start to increment. Once it gets past 5, then it will actually indicate to the user that we do have an airflow problem. So I'm going to go ahead and cover my hand over it now, and then we'll wait, and you can see the probability counter start incrementing on the UART screen. So here I go. And then you can see it goes back to state 1, and then if you look back here, you can see that we have an alert to the user. We have 2 indicator lights that says you have a potential airflow issue. So in this case, what we do next is the user will change the filter, and then they will push this button, which will reset it, recalibrate the system, and then we continue to go on. That's TID Design 1070. Like I said, airflow issues. We're trying to solve that problem right here with this device. Coming to you shortly.